What you see here is a demo. You have the camera over here. It's looking at the conveyor belt. It's checking out all the height differences of the different objects. And this basically shows you already the biggest differentiator of this new product. It can actually tell you the depth on moving objects, which, on contrary, all other suppliers, our competing devices, are not able to do. The device, and that's the nice thing about this product family, calculates the depth on chip. So you don't need an expensive FPGA, memory, whatever, to do this for you. We do this for you on this sensor. In addition, it is able to capture depth information on the distance between pretty much 0 and 30 meters, so 30 meters, with an accuracy better than 0.5%. So 30 meters, 0.5%, I think that corresponds to about 15 centimeters, which I think is pretty accurate. We do this by measuring phase shifts of light pulses, which is a technique that also somewhat automatically removes the influence of ambient light. So the sensor will give you depth information in a rather dark environment or even in bright sunlight, and is able to differentiate between the different conditions. So over here you see the sensor. There are 4 laser diodes basically emitting the pulses for the depth measurement, and they're pulsed so fast we can't see it with our own eyes, so you have to trust me on this. This is the pulse modulation. So by the way we actually pulse the lasers, how we measure the light, it allows us to measure the distance to an object, between the camera and the object, the local differences, or the local distance between multiple objects, and then the distance from the last object back to the camera. So you also have relative distances as well as the distance to the camera, and that allows us to enhance the accuracy as much as possible. Now, I mentioned 0.5% accuracy. Now in this demo, this distance is about 30-40 centimeters. There are objects over here like this whiteboard here that has local height differences of 1 to 2 millimeters. And if you look at the screen at the moment this object passes, you can clearly see the different colors, the color shading, proving that it's able to capture the height differences. Because it's a small chip, the costs are reasonable. You basically pay for the silicon with some IP. Package is small, so it also allows you to develop a very small format camera. Now, the traditional method of depth measurement, for example, is like stereo vision, just to give you an example. But stereo vision means that you need to have 2 cameras. The 2 cameras need to be separated at some distance with some mount or whatever in between. That automatically creates like a large camera, a large device. Now in this case you can actually see here it is a small device, and then 2/3 of this are basically the PCBs we need to read out and connect it to the onsemi standard evaluation platform. So it's not even part of the real camera. Frame rates. We acquire the images and the depth information at 60 frames per second, which is fast enough for all the applications I can come up with. And also during the show, it is clear that we are not following a market trend with this device. We're not creating a part that's like Me Too. In this case, we are setting the market trend. We are creating ideas for our customers. There will be applications, and already have seen applications popping up that nobody could have imagined at the start of this development. So again, we are creating a new market trend with this product family. People can buy them with or without the depth calculation on chip, to whatever you like, whatever you prefer, to integrate it as easily as possible into your own system. In case of any interest, in case of any questions, feel free to contact your local onsemi sales representative. They will get in touch with the BU and will be happy to answer your questions. Check out the website for more information.